Hi, welcome to Pencil College. In Chapter 12.1, we'll be learning about some simple trigonometric identities. Okay, so here are the lesson objectives for this video. Firstly, we'll define the secant, cosecant, and cotangent functions. Next, we will apply some simple trigonometric identities to simplify trigo expressions, prove other identities, and solve some trigo equations. Okay, so just a quick introduction to some of the trigo functions which are slightly unfamiliar, okay, to you. So tangent theta is defined as sine theta over cosine theta. Okay, and the secant of theta, okay, which is spelled in this way, secant theta, is defined as 1 over cosine of theta. Next, the cosecant of theta, so spelled as cosecant, is defined as 1 over sine theta. Okay, and lastly, the cotangent of theta, spelled like that, cotangent of theta, is defined as 1 over tangent theta. Okay, and if you were to substitute tangent theta equals to sine theta over cosine theta and simplify, you will get cotangent theta equals to cosine theta over sine theta. Okay, next, 3 identities that you need to be familiar with by the end of this video. Okay, so the first identity is as such: the sine square of theta plus cosine square of theta is equals to 1. Okay, next, 1 plus tangent square theta equals to secant square theta. And lastly, 1 plus cotangent square theta is equals to cosecant square theta. Okay, so at this point in time, let me point out two important things. The first thing is that sine square of theta is equivalent to sine theta squared. Okay, and the next thing that is important is that actually all these 3 identities can be found in your formula list, okay, for O levels. Okay, therefore there is no need to memorize these identities. Okay, and in this video, whenever I'm using an identity, I will leave it at the top left hand corner of the screen. Okay, so without further ado, let's look at some examples. Okay, in example 1a, okay, we are asked to simplify this expression over here. 1 minus cosine square theta equals to over 1 minus sine square theta. Okay, so if we look at the first identity over here, okay, you realize that if I were to shift cosine square theta to the right hand side of the equation, I will just get sine square theta equals to 1 minus cosine square theta. Okay, so over here my numerator can be replaced by sine square theta. Okay, next, going back to the first identity over here, you realize that if I were to shift sine square theta to the right hand side of the equation, I will simply get cosine square theta equals to 1 minus sine square theta. Okay, so I can replace the denominator of this expression with cosine square theta. Okay, and remember what I mentioned in the previous slide, sine square theta is the same as sine theta square. Okay, so similar for cosine square theta. I can express it like that. And finally, I can bring out my square function. Okay, so I'll write it as sine over cosine theta, the whole thing squared. Okay, and recall that tangent theta is equals to sine theta over cosine of theta. Okay, so this function over here is simply tangent theta. Okay, and finally, if you want, you can bring in the square to make it look like this, tangent square theta. Okay, that's all for example 1a. Let's move on to example 1b. Okay, so in this expression, okay, I'm asked to simplify, okay, what I see over here. So what I will do, okay, in the numerator, okay, if I were to simplify things, okay, recall that a plus b times a minus b is simply a squared minus b squared. Okay, so in the numerator, I will just, okay, identify my a to be 1 and my b to be cosine theta. So I'll just get 1 square minus cosine square theta. Okay, and recall in the previous example that sine square of theta, okay, using the first formula here, sine square of theta is just equals to 1 minus cosine square theta. Okay, so if I were to replace my numerator with this function you see over here, okay, I will just get sine square theta. Okay, and then cancelling sine square theta and sine square theta, I will just be left with 1. Okay, that's all for example 1b. Okay, I'll see you in the next video for example 2, and I hope you like this video. For more videos, please log on to pencilcollege.com. See ya!